No? Okay, so now let's look a little more in depth of each of these. We already talked about Q quite a bit. Let's talk about work. Okay, work and heat. Let's first talk about work. Does anybody know what the physics definition of work is? Like, what's the equation equal to? Yep, it's force times distance. F times distance. So we have a force. We're applying that force over a distance. Anybody know what the unit, the conventional unit is for work or energy? What was it? Yep, joules. The unit is joules. And the other important point is it's not a state function. It's one of those path-dependent functions. So it depends on the history, what you've done to it, where it moves, and the path you take. Just like last time where I had a race against Geo, I tried to get to the end and I took a weirder path, right? I ended up doing more work because of it. Okay, but now if we consider an ideal gas, it's either expanding or contracting. The work in this case is equal to negative pressure times the change in the volume. And this is known as pressure volume work. There's a bunch of different types of work, like there's electrical work, there's mechanical work. The one we're going to talk about is pressure volume work in this case. Okay, so let's consider the units real quick. Okay, we know we have to get to joules, right? We have a force times a distance that gets us a joules. But let's look at this expression. Work is equal to negative P times delta V. And what did we say? What's a pressure equal to again? How do we define pressure? It's something over something. You remember? Yep, a force over an area. What are we going to report our force in? Yeah, we usually do newtons. For now, let's just keep it as F for force. Or actually, no, I lied. We'll do newtons. Let's keep newtons. We're talking about units. And what about an area? If we had to keep SI units, what would that be? Yep, meters. If it's an area, not cube, that'd be a volume. Yep, squared. Okay, now let's plug this into here. So we'd have negative newtons over meters squared times, what about a volume? What will we keep track of a volume in? Meters. So this was an area which was squared. What about a volume? Yep, what was that? Yeah, it's cubed. So multiply that through, what are you going to get as a result? So what cancels? Yeah, we get newtons times Newton meters. And if you look, that's almost the same, well, that is the same thing here. We'd have a Newton times a distance, which is a meter, and it ends up being a Newton times meters. If you break down the SI units, what you can do is you can see that that actually is equivalent to a joule. So if you have a pressure times a change in the volume, you're actually getting the exact same units out as you would for like the regular force equation. Okay? That's why we're using a pressure and a volume. Any questions about that? Okay, let's look at an example. Example, a gas is compressed. From 2.0 liters to 0. Actually, I'm going to add another 0 on this. To 0.75 liters. At a constant temperature. And against a pressure what do we have as our pressure? Of 2.0 atm. I want you to calculate the work done in joules. In joules. Try purple again. What are we looking for in this problem? Work. Trying to find work, right? Work in joules. Can you guys see that purple in the back? Or is it too hard to see? Good? Okay. Tell me some important information. What stuff is going to be of value in this? Yeah. Yep, you got the change in volume. So we got that. Give me something else that's important. Yeah. Pressure. Yep, pressure. Victoria, is that what you were going to say? Yeah. Or did you say it? She said it. Okay. Is there anything else that's valuable that can help us out to get to determine the right or wrong answer? Yeah, what do you think? Constant temperature. That is important because we know we don't have to mess with temperature. Any other things? There's one other word in here that's going to let us know the magnitude, or excuse me, the sign of the work. Yep. No, actually this compressed. Oh, and actually, yeah, because it's set against a pressure. Okay, so we've got some words that can help us out. We're basically boxing like the whole thing, right? Okay. We want to find work. The only equation we have in this course for work is equal to what? Yep, negative pressure times delta V. Okay, what's our pressure? Yep, 2.0 atm. Okay, delta V. It's always what minus what? Final minus initial. What is my final volume in this case? Yep, 0.75 liters minus our initial volume, which was 2.00 liters. Okay, you do this math through, the value I get is 2.5. What are my units? Just looking at that, tell me the units. Joules. Not joules in this case. What are they? Yep, ATM times liters. So what do we have to do to this value? Yeah, we got to convert it to joules. So we got ATM liters at the bottom. What's going to go up top? Yeah, joules. And you can look this up. It's 101.3 joules for every 1 ATM liter. I'd give that to you. You multiply that through, how many sig figs should my answer have? Yep, should have 2 in the end. I get 2.5 times 10 to the second joules. Now, that is the right answer. We have the right sign. Is work being done to or by the system in this case? So the word compressed, what does that make you think? Work done to or by? Yeah. Yep, work done to the system. Okay, what does that mean about the net or the sign of work? Is it going to be greater than 0 or less than 0? Negative or positive? Is energy entering or leaving the system by being squished? Entering the system, right? Because I take this podium and I apply a pressure to it. I'm putting energy into the system to cause it to move, right? So energy is entering the system. Does that mean work is positive or work is negative? Yeah. So does our sign make sense? Yeah, we should get a positive workout because we're having energy enter the system. Okay. Now let's add another bit to this. Am I okay to erase this? All right. So now let's say we have the same thing, but instead of a constant pressure of 2.0, we're against a vacuum. So, example, same thing, but against a vacuum. 2 C's, 2 U's, 2 U's, right? Right? Sure. So in that case, what's the total work done? Well, let's hop back to the work equation. Work is equal to what in this course? Yep, negative P, delta V. Okay, what's it going to be equal to then? You say the word vacuum, what does that mean? Well, what does vacuum mean? What do you think, Will? Yeah, there's no air, right? So what does that mean about the pressure? Yeah, 0. So what's the work done? Yeah, there's no work done. So if you're against a vacuum, it's not, you're going to have a 0 amount of work done because there's just no pressure. There's no pressure in terms of this equation. That's a 0. They're multiplied together, resulting in a 0.